Hello and welcome back to another video. In this problem, we're asked to use continuity to evaluate the limit. We have the limit as x approaches 4 of 3 raised to the power of the square root of x squared minus 2x minus 4. So the way that we're going to use continuity to evaluate this limit is first to take this function and split it up into two different functions. So we have f of x is equal to 3 to the x, and g of x is equal to the square root of x squared minus 2x minus 4. Now, how do these two functions relate to this one? Well, this is the limit as x approaches 4 of f of g of x, right? Because we're plugging in g of x into the spot where x used to be in f of x. And we can say from theorem 9 that if for the composition f of g of x, if for some value a, which we can call 4, if at 4, g of 4 is continuous, right? To say that g is continuous at 4, and f is continuous at g of 4, f of g of x is continuous at 4 as well. And we can say from theorem 7 that f of x, which is an exponential function, and g of x, which is a root function, these functions are continuous over their domains. So as long as f of x and g of x are defined, and f of g of x is defined at 4, we can say that the function is continuous, which is to say that the limit as x approaches 4 of 3 to this power, this is simply equal to this function evaluated at 4. So 3 to the square root of 4 squared minus 2 times 4 minus 4. This is 3 to the square root of 16 minus 8 minus 4. 3 to the square root of 4 is 3 squared is 9. We can say, therefore, that the value of this limit is 9.